I extend a very warm welcome to all of you for today's session of AICTE Training and Learning Academy sponsored Basic Faculty Development Program on Global Warming Prevalence for Climate Friendly Energy Production. And it's my pleasure to introduce our chief guest, Dr. B. Mahesh Kumar, Associate Professor in the Department of Electrical and Electronic Engineering, Puducherry Technological University. With over 30 years of teaching experience, he has dedicated his career in the fields of special electrical machines, electric vehicle charging technology, and energy engineering. He has guided 25 UG projects and 22 PG projects and has successfully supervised 2 PhD scholars while currently guiding 3 more. His impressive academic contributions include 20 publications in reputed international and national journals, including Elsevier, and 25 conference papers, including IEEE conferences. He has also conducted major academic events such as International Conference on Advances in Modeling, Control and Optimization of Electrical Systems in 2020 and a special course on Electric Vehicle Charging Technology in 2021. He is also a life member of ISPE and SSI as well as an associate member of IE India. With his rich experience and expertise, he continues to inspire innovation and excellence in the field of electrical engineering. We are extremely happy to welcome you, sir. The session is yours.
Thank you very much for a nice introduction. Is it audible and back? Audible. First of all, before I start, I would like to thank the organization for inviting me for delivering this topic on the renewable energy. Okay, so before I start, I would like to know, I think all of you belong to 500 is it? In addition to that, most of the faculty members will be sitting. So the faculty members sitting, I request you to raise your hand just to know how many faculty members are attending. 1, 2, 3, 4, 5, 6, 7. Okay. And all the 5 students belong to EEE. Any other discipline, whether they come here from a different discipline, only EEE. Mechanical. How many of you from mechanical? Raise your hand. Yeah, good. Because before I start, I should know with what type of people I am going to meet. Okay, good number. Very good. Anyhow, this topic is a emerging one, and if you want to mention, it is emerging in the field of electrical engineering, sustainable energy, that is renewable energy, and second one is electrical vehicle technology. These two topics are emerging, and they are going to put a large number of employment opportunities, very potential areas, not only for EEE, even to some extent mechanical. Because electrical, mechanical always related. When you go to thermal power plant, without mechanical engineers, we cannot produce electricity. So, before I start, I will let me tell about what is the current scenario. Here, I am not going to discuss anything technically deeply, so you don't have to worry. My classroom, that this kind of lecture will be interactive. If you have anything, can interact. In between, if you have any doubt, you can ask me. And this is not going to be highly technical. Of course, there will be some information. I will give some data about what is happening in this sustainable energy field, what is currently going, what should be done, and where we are marching towards. All those things with respect to our country, with respect to our states in a different region, and also in the world level, what is our position in various sectors. I will give an overview about all those things. It will be an introduction for all of you. Okay. So, what is sustainable energy? Sustainable energy, all of you have already seen. It's environmentally responsible production for use of energy that meets person needs without compromising future generation ability. So that is underlying. That means when you keep on using your energy from different sources like thermal power plant, nuclear power plant, there are so many types of power producing plants. And particularly this sustainable energy has to sustain for a long time without depending on anything. So here, what we produce from thermal and other source will not be sustainable because there are two factors. One is Your energy depends on your fossil fuel. It should be available. If you don't have a fossil fuel, you cannot produce energy. It may be coal or lignite or oil, it may be anything. There should be a source. Only from that you are producing energy. Second thing, whether the energy that is produced from these sources will be helpful for our health, whether it pollutes atmosphere. If you look into those issues, it is polluting a lot. That is the reason why at international level people are coming and advocating that we should not open any more thermal power plant, even nuclear. So nuclear objection naturally comes for safety first, but thermal is not affected initially. But there's a pollution part. So that is the reason why people are now thinking about we should not go for this polluting type of energy producing power plants. Okay. So it involves. So if you say what are the other methods how we can produce power, it starts from solar, wind, hydro, geothermal, tidal. I will just touch upon all those things. But here I have underlined only solar because that is only contributing a lot in this scenario. Not only in our state, not only in our country, even in the international scenario. If you look at the data which I will be presenting now, if you see these two sectors are emerging a great extent. At one point of time, they may overtake all the power producing sectors and they will take a lead role. So that is our aim. Okay, so there are so many organizations connected to they are coming with a lot of projects, projections, estimated target. So how to curtail all this pollution from different sectors. Okay. Third point, the transition to sustainable energy is crucial for combating climate change. So climate change is a big problem. You would have seen in meteorology department, many people used to say there is a sudden temperature rise, there is a sudden change in the climate, sudden heavy rain, there is no rain in some areas it's very drought, and pollution is also. So all these climate change and polluting elements are coming only because of this fossil fuel based power production. Okay. So we have to worry about what are the problems we face in climate change? What should we do? What are the problems associated with that? If you look at first problem, temperature rise. Temperature, all of you should have studied global surface temperature is normally 15 degrees Celsius average, they say. But it keeps on rising. Every year the temperature rise gives a big problem. And when the temperature rises, it affects our weather conditions. And normally when the temperature rises, the icebergs which are available in the Himalayan region, when it starts melting, it rises a sea level. So that is another big problem. And changes in ecosystem. When the temperature is even the animal, the forest area, which are all normally getting a particular temperature, when the temperature is widely changing, they also get into problems. So all these problems are coming only due to this climate change. The climate change comes due to this polluting power plants. So that's the reason why. Now, who is going to control how to do this? So the global climate change, there are two authorities, major authorities. One is United Nations Framework Convention on Climate Change. UNFCCC is a major authority. Now they are only looking into these issues. And the other, they have, I think in the recent 2015, we have seen the Paris Agreement. Many countries came together to sort out this polluting problem from different power plants. So Paris Agreement was one of the starting point to stop this pollution and to give an encouragement for all these renewable energy sectors, starting from solar, wind. So what that says is a parent treaty for global climate agreements like the Paris Agreement and supports a global response to climate change, while IPCC provides the site. IPCC is another organization, Intergovernmental Panel on Climate Change. These two organizations at the world level sit together and sort out all the issues. In addition, there are so many associate bodies which I have not mentioned here. It keeps on going for a long time. So that's why I have cut all those things. I am just dealing with the major. So this Paris Agreement, they say every year, recently what they have announced from the international body, the temperature rise should be kept within 2 degrees Celsius. It was 1.5, 1.6. Recently, if you take 1.6, 1.7, if it keeps on rising every year by the magnitude of 0.5, even we have the graph. I will show the graph. Okay. Use the graph. If you see the graph, average global temperature rise starts from 13.8 and 14.1 was sustaining from 1940 to 1980. It was not changing much. But after 1980, after the Industrial Revolution, when a lot of power plants came into picture, there was a sudden rise. It was an exponential growth. It's not an ordinary linear growth. You will see from 1980, are you able to see that? So from 1980 onwards, the rise in the global temperature was very high. This was realized, and that is the reason why all these international bodies came together, representing from different countries and analyzing this problem, where these problems are coming from, how to sort out. The discussion was started only because of this sudden rise in the temperature. Because of sudden rise in temperature, what happens automatically? All the problems like climate change, temperature rise, iceberg melting, ecological change in the system, all those problems are coming. So if we keep on continuing without noticing all these things, what will happen to future? Of course, you may enjoy today. To some extent, your next generation, your children may enjoy. Your grandparents, definitely they will go. Because a lot of health issues are coming. Air quality is changing. So unless you address this basic structural problem in a war-footing measure, it will lead to a lot of problems in future, not for you, for your future generations. So this graph tells how the rise in between that there is a rise. If you see again from 1980, the rise in the graph almost 2020 it has touched 1.6. That is the reason why they have kept at 1.5. 2 is maximum which we can reach within a short period if we didn't notice this. So when something goes beyond the limit, controlling bodies will come into picture and they will say this has to be maintained within the prescribed. Otherwise, it will create a lot of problem in future. So I have shown in-depth graph how the rise in between, like a share market, if you see there will be rise, but average graph will come in the red color. Okay, so the sudden rise should be noted, and it is. So the global warming, it is coming due to so many reasons. So one reason is distance from the sun is not in our control, because if you see summer, we are very near to sun. Earth is very near to sun. Whereas in the winter it goes. So that is one reason why the temperature changes. Another reason is greenhouse. Greenhouse emission is a problem where it forms like a blanket and it completely absorbs the heat from the sun and it raises the temperature of the earth. It forms like a blanket around the earth. So this greenhouse gas emission should be controlled. So that is the reason why these problems are addressed in the renewable energy sector. Okay. So that is the reason why we switch over to renewable energy. Now it is going to power a safer future. Of course, it's going to give power, but this power will be safe for your future without any problem. That is the reason why we say this is a sustainable. It's going to sustain for a long time. All the power plant will come only for a short time, because as long as a fossil fuel, I have data, as long as a fossil fuel is available in our country, we can enjoy. Once it is completed, once it is completely exhausted, where will it produce power? It's a big problem in power production. Okay, so power needs to be produced continuously, because we have become totally power dependent. Without power, we cannot survive. Even if 1 hour power cuts, that's all. Sometimes some houses they may have inverter, some houses they may have generator. Power plant, all the industries will have their own generator set. But how long it can maintain? So power should be available continuously without harming the society. Okay. So a large chunk of the greenhouse gases that blanket the earth and trap the sun's heat are generated through energy production. So energy production sector is only contributing a lot in this global. I have a data from the energy sector how much harmful effects like emission of CO2, SO2, how does it affect our health? Okay. And fossil fuels such as coal, oil and gas contribute a lot. And they say accounting for 75% on global greenhouse gas effects. 78% is only the fossil fuels. So science is telling very clearly to avoid the worst impact of this climate change, emission need to be reduced by almost half by 2030 and reach net zero by 2040. This is a projection pointed out by the international bodies. Unless you start controlling or switching over to some other mode of power production, you are able to reduce off the current pollution by 2030. And if you go in that direction, by the year 2050, our emission will be almost zero. We will be zero emission power producing plants all over country, all over world. It's not only the state countries, but every country should contribute, because if I have all the renewables, some countries are still producing thermal, that will reflect in the overall. Again, I have a problem, though I have changed it. But my neighbor is not changing it. It's a global problem. It's not an individual problem. Somebody pushes something in the air, it goes through the space, and it may create a harmful effect to anybody. That is the reason why they all come together. Okay. So, another important thing, fossil fuels still account for more than 80% of global energy production. Globally, if you look at energy production, fossil fuel is contributing 80%. It's a global level data. Cleaner source of energy is gaining ground, and it is now 29% of electricity is coming from renewable energy. So now it is only 29 to 30, almost one third. Okay, from the renewable sector. So what should we do? Why should we go for this renewable? Okay, there are major findings. All these details are taken from the International Renewable Energy Development sector. And there are, even in our country, MNR is there, Ministry of Renewable, non-term, that is new and renewable energy sector. And in our country also, Indian Renewable Energy Development Agency is there. All these bodies are looking into these issues, and they are conducting conferences. They are calling all the people who are working in the sector, renewable energy sector, like solar, wind, geothermal, all the sector. They are coming and they are conducting conference. They are telling their output in the scientific developments and what should be done, how the rate goes, how it should be controlled. All those things will be discussed. Okay. So first point is, energy sources are available all over us. Everywhere, even today also you can get sunlight. And not only here, everywhere, all the country. Maybe the magnitude may change. Exactly at 12 o'clock, it will be at peak value. Morning 8, evening 4, almost it is available. Maybe from 8 o'clock it will be a little bit, the concentration, intensity of the light will be very less. Maybe as it goes to 12, peak. From 12 to 4 again it goes down. But it is available. Okay. It's not only that, even water, hydropower plant is available. And wind is available. It's free of cost. You don't have to pay anything. For taking fossil fuel, you have to spend a lot. You have to provide a big, because if you take a NLC, Neyveli Chemical, there's a big unit. Large number of people are looking. It's a very big organization employing large number of people and taking the coal and processing it. And in fact, if you do all those things, finally what this is, my research conducted on this gets that our coal content is almost 40 to 50% ash content. Whereas if you see other Indonesia and other countries, they have only 25 to 30%. So even after doing all those things, if you take the coal from the capital for power producing projects, it is not efficient. And it is cheaper. I don't have to pay anything. It is available freely and nobody will charge for that. If I take the air from this side, nobody. I don't have to pay to anyone. And it is healthier because I am not disturbing. It is not going to pollute all the solar, wind, geothermal, tidal. If you take any biogas plant, they don't harm, they don't pollute as pollution comes from the conventional power plants like thermal and nuclear. Where large amount of CO2 emission is emanating. Okay. And it is going to create a job. So job opportunity actually in the initial stage, very good job opportunity for both this energy sector, because when you see the paradigm shift from the existing conventional power plant to this renewable energy sector, there will be movement from people side. People who are working in the conventional plant, they can go and join because there also are going to have generator. Only thing, the power source is changing. There it was coal. Here it is solar. Of course, mechanical engineers will also come and play because while designing the solar panel arrangement, while fixing the wind plant, mechanical engineers will play a role. After the generator, electrical power comes into it. Electrical engineer will come and play a vital role. So before the power production, it goes to mechanical, to some extent civil engineer, because to put the base foundation for all the wind plant, even for solar, they will contribute. But mechanical design is more important there. You see the contribution, civil is little bit, mechanical is something, and electrical is one major contribution. Okay, because after the power is produced, it has to be processed to different stages, only big power processing elements, like converter, rectifier, generator, motor, transmission, transformer, all those things will come. Only we people will do that. So after getting job, it gives an economic sense And this, they say 80% global population lives in countries that are net importers of fossil fuel. Some countries, if they have a fossil fuel, they will do. Suppose, even in our country, if you say, we are not only producing fossil fuel, we are also importing. So when the fossil fuel is imported in larger quantity, another problem is, we have to pay, because finance and research should be maintained in our country. Suppose today, let us say I am buying $1. Can anyone tell what is the rate of $1? Rupees. 80?
Around 85, 89.
85. It is fluctuating. Okay, very good. Let us say 85. So now I am buying $1. 85 rupees I am paying and I am getting the crude oil from, let us say, US, because I am transferring in terms of dollar. Suddenly my value, rupee value depreciates. It goes to 90. But oil value doesn't change. Oil cost is still remaining, but my rupee cost is going down, so I have to pay more. Suppose if it is 90 from 85, I have to pay additionally 5 rupees even for the same rate of crude oil. So this is another problem in this. That means if you keep on depreciating your rupee value when you compare with the international platform of currency level, automatically what happens? You will have to pay more. The money will be in that to a larger extent. In addition to your payment for your code, which is also polluting, which will affect our health in future, for which you have to again pay in health sector. Lot of implications are coming. So Canada's renewable resources are available in all countries and their potential is said to be fully harnessed. It is not yet fully harnessed. It only started. In some countries they have reached the top. For example, I can say China, the leading one. 25 years back, I have data, I'm just telling. There are some the countries which are all growing at a higher growth rate. They are all growing at a higher rate of the growth rate is high, they will reach the position on first rank quickly. If the rate is low, they will take long time. Sometimes they may not be able to reach, somebody will overtake because those who are going at a higher rate only can win in the competitive environment. Okay. So International Renewable Energy Agency estimates 90% of the world's electricity can and should come from renewable energy by 2050. So that is their projection. By 2050, 90% of the power should come only from renewable energy. But even at that time, 10% may come from any sector other than renewable energy, which is not good for our health. Okay. It is cheaper. If you see, the cost of the solar, which was very high long back, now it has cut down drastically. The cost of electricity from solar power fell by 85% in 2010 and 20. So during this period, there was a heavy research going in the solar panel, which pulled down the cost of solar panel. Because of that, the total solar power plant estimation projects has come down drastically. And the cost of offshore and onshore. You know what is onshore, offshore mean? Onshore means on the land, offshore means on the seaside. Ocean sea. They may be on the seashore. Wind energy fell by 56%. The main reason is one is due to technological advancement in that particular field. To do something in material sense to improve the conductivity of solar cell. And the wind research is going. Second side, large production. If you want to minimize the cost of any product, if you make one product, it will be costly. If you make 1,000 products, it will be cheaper. If you make 1 lakh product, the same quantity, 1 lakh product if you make, definitely. Now everyone is pushing towards renewable energy means automatically the cost will definitely come. So by the mass production, we are able to minimize the cost. And also due to technological advancements in the research field, it is also trying to pull down the cost. So that is the reason why people are now switching on. Otherwise people will not switch on. So falling prices make renewable energy more attractive all around, including low and middle income countries where most of the additional demand for electricity will come from. This is a major scenario. The falling cost is a real opportunity for much of the new cost. I will tell you one thing. 20 years back, people didn't have thought about the energy that they can produce from the house and export to grid. Getting the power from the grid itself is difficult because we are not able to meet the supply demand. Supply is less, demand is more. If you go and see in EV, there are a lot of people waiting in queue for getting power supply. It will not be given immediately. They have a time schedule they will give. It is going in a systematic manner. What is the reason? If everyone is given suddenly, of course, let us say residential sector they are giving because the load is less. Industrial sector, where the power requirement is very high, they expect not in terms of like in house. Let me ask one question. Anyone can tell what is the average load in an Indian house? the normal category, middle. Or you can tell what is your load in your house in terms of kilowatt. Anybody? Electrical engineers can answer this question. You can say roughly 10 kilowatt. I am telling installed. But at that time, if you see, it need not be 10 kilowatt. I am not using. I am using 5 kilowatts. Depending upon the time in the morning, then there will be heavy rush. Every load will be running. Motor will be working, kitchen, all items will be running, fridge is running, pump will be running. But after 9, 10, everything is only very few loads. And evening after 6 to 10, there will be heavy loads. So it will be fluctuating. So though my installed capacity is 10 kilowatt, I am using only 5 kilowatt the maximum. But load will be different in a different location and I am using a different time. Okay. So 10 kilowatt, and even for this I am not able to get from the government. But now government, once the government opens avenue for exporting your power to the grid, government say problem has come because they are not able to meet the demand, they are not able to generate because the load is more. So if you start producing and if you pump the power into grid by your own solar or wind, the wind we cannot have, but solar we can pump. And in Pondicherry they have. In fact, yesterday I spoke to one of the solar power making plants. They are going to, even you can even get 5 rupees. They have, so far they have been subtracting from the power you take from the grid if you sell. Suppose I am consuming 10 units, but I am giving 5 units to grid. So 10 minus 5, only for 5 units I will be paying. Because I am giving some unit, I am taking some unit. If I take more, I have to pay little. Because after the unit I am already supplying the grid. Now they are going to fix the amount for power that you are going to feed the grid. It was telling around 5 rupees per unit. So this is a scenario now facing. 20 years back it was not even possible to think. I am not able to get how can I export the power from my house to the grid. So this is a scenario changing. Not only in our country, international scenarios. And it is healthier. WHO, if you see 19% of people in the world think, yeah, that exceeds air quality limits. So if you pollute the entire atmosphere by having a lot of thermal power plants, fossil fuel-based power plants, pollution comes, first it affects the respiratory system of our human. 19% problem comes. This is a report delivered from WHO. All of you know what is WHO. World Health Organization has reported. So unless you do something for this, now it will not. It's a slow poison. Those are doing exercise, those who are eating good, those who are doing all kind of. They will extend their life to the extent possible. But those who are not doing anything, junk food, no exercise, respiratory problem, they will immediately. So unless you do something for this, your life cannot be extended. It is the problem. Somebody is doing something, I am just losing my time. So that is the reason why people are coming together to sort out this international issue. Okay. And if you see, the unhealthy levels of fine particulate matter and nitrogen oxide originate mainly from burning of fossil fuel. Nitrogen oxide is one of the serious issues. In 2018, air pollution from fossil fuel cost 2.9 trillion in health and economic costs. So it goes to the trillion level. It is not a one day or one person. Somewhere somebody gets, it's in that region, in that state, in that country, similarly all countries. Put together, it becomes a big trillion-dollar problem for the entire world. So switching to clean source of energy, such as wind and solar, will address this climate change problem. Okay. Now, air quality in this, can anyone tell what is the prescribed air quality limit which we can consume, which we can breathe? There are some states, some important cities which is highly polluted. There are some cities which are good. I have a list. Just a matter of curiosity I'm asking. At least you should know which city is completely polluted, which city is good in terms of air quality index. Delhi, okay, everyone would have read because it's a news coming, particularly in the winter season. Delhi low pollution, it's coming. Yeah, it is in the list. If you see, before that, I would like to show what is the level. Before you go into that, what is the permissible level? 0 to 50 is good in the air quality index. It is satisfactory. Moderate 51 to 100. Okay. Though it poses a risk to individuals who are unusually sensitive to air pollution, it is somehow accepted. Unhealthy for sensitive groups 101 to 150. Sensitive groups, some people will be having a respiratory problem. For this 101 to 150 group, they have a very big problem. And unhealthy 150 100 is unhealthy for all. And it is dangerous 201 to 300 and hazardous 301 to 500. This is a scenario you should know. What is the level in 9 million jobs additionally? So though I subtract that 5, 14 minus 5 comes to 9. So still it is on the rising side. Okay, so switching workers, for instance, to take a new roles in manufacturing electrical vehicles. Electrical vehicle is also another sector which is helping in this, because electrical vehicle I am taking with the renewable energy only, and I am not using any again petrol fuel for running my vehicle. I am only going to use battery. Battery is going to get charged only from renewable energy. So totally I am removed from the polluting process. Okay. So ensuring just transition, facing the needs and rights of the people and heart of the energy transition, if you paramount to make sure no one is left behind. Nothing should be left. They have to completely change the systems. And if you see 16.2, this is International Renewable Energy data says, over 16.2 million people were employed in the global energy sector. The solar being the largest employer, supporting 7 point. In the renewable energy sector, if you see, after analyzing the data, I came to know that the solar is a leading one. Because it's available everywhere, cheaper, daily it is available. Wind is available for a particular season, then it will go. Maybe for 12 months, it will be available for 4 to 6 months. But 4 to 6 months, you can harness potential fully. It will go to the maximum. So, so when the wind force is more, you are able to tap large amount of energy. The problem with the wind is we are not able to do. As an individual, you cannot do. It goes only in the industry, because amount invested is low. Industry people are giving, they are given concession. If you make this power plant, I will give concession. And if you give power to the grid from your wind farm, again they are giving concession rate. So all those things are available. So that is why wind is available in an area where it is, where the wind pressure is more. I cannot put only one. When the area is totally available with a heavy pressure, put large number of windmill, that becomes a wind farm. So India's renewable energy workforce already surpassed 1 million. 2023 it has surpassed 1 million. Future growth will create opportunities for skilled professional technicians. As a technician diploma will do. Skilled professionals be. And local entrepreneurs, they will become an industrial leader. They will do a job, not that working with someone. They will create a job. Not to create the decentralized energy sources. Okay. So solar wind will take a lead role in this sector. So if you see the economic sense of project, they say in terms of trillion, because once it goes to world level, we will never talk in terms of million, it goes to trillion. About 7 trillion was spent on subsidizing the fossil fuel industry in 2024, including explicit renewable tax break, health and environmental damages. So finally, in comparison, they say 4.5 trillion a year needs to be invested in renewable energy. So expected investment, it comes to 4.5 million by the 2030 they have to do, including investment in technology infrastructure allows to reach net zero emission by 20. So 2050, like if you want to reach the stage where zero emission, you have to continuously feed the money. You have to pump it large amount of money should be pumped into this kind of projects like solar, wind, and by 2050 they say it reaches zero emission. Okay. The reduction of pollution, because it not only produces power, it also solves our problem. The reduction of pollution and climate impacts alone could save the world up to 4.2 trillion per day by 2030. So these are the data that we are taking. So this much amount every day you are able to save. So that is the reason why we switch over to this. Okay, let us say fossil fuels, certainly how much is available. We are talking about a complete closure. If it is available, we should waste it. But we should not use, we have come to the conclusion that it should not pollute further. No, we have to stop immediately. That kind of decision we have reached. But you have to see what is available. Around 651.8 million metric tons of recoverable crude oil reserves have been identified in India's sedimentary basins. Still it is available. Natural gas, 1,138.6 billion cubic meters. Coal, estimated reserves 364.14 billion. So this is available. Okay, if it is available, how much duration it will come? Okay, sir, it will come for only 5 years. I will use a nut probe. We can come to the conclusion. But is it so? If you see the next slide, it comes for almost 200 years. And globally, oil is projected to last for 50 years, and natural gas for about 53 years. If the current consumption rate continue, highlighting the increasing importance of India's shift. So, if you continue to do all these existing power plants with the coal, oil, and other gas-based things, will run for another 50 years. By the time our pollution will reach the top and the population will come down, not because of birth rate fall, it is because of death rate increase. We understand the problem. This is a major problem. That is the reason why every year conference is conducted to know what is the level at which the temperature rises in the earth, climate change, why it happens, what should be the projection for renewable sector, all those things should be addressed. Okay. Now let us see coming how much CO2 emissions comes. Now this graph will tell you, pie chart will tell you from which sector emission comes. The energy sector 26%. Energy sector means our power producing energy. Okay. So the energy power is almost 26%. Industry means there are industries which consumes large amount of power and they do some process. Like for example, let us say cement industry, sugar industry. There are so many industries. They also pollute. Their pollution comes to only 10 to 11%. Transport 15%. Previously it was less. When the number of two-wheelers and four-wheelers increased, it has become violent. Almost it is touching 15%. But transport also it is in our control because if you switch over to a completely EV-based model, it is almost zero. Because again, transport comes only from fossil fuel. It may be petrol, or it may be diesel, or it may be anything, even gas. Buildings will also do some kind of, because for building, suppose today I am constructing this building. For this building, I need cement, I need steel. Those things are coming from only after burning some fuel, and it goes to only then it comes here. And after coming here, the item what we do here, whatever the emission, here there will be cooking, there will be heating. This will also slowly emit. So building around contributes 6%. And fuel production, petrochemical sectors, when you take petrochemicals, crude oils, they also contribute 10% in the emission rate. Okay, so agriculture 11%, and other things little bit. So this will tell you how this is coming. Okay, these are all coming, sir. Who is a culprit? Who is polluting more? That fellow should be stopped. Otherwise, the fellow who is polluting with a little bit, less amount, need not be stopped immediately because the contribution is less. Who has to be arrested? The major crime only should be immediately arrested. The minor should not be. Then suppose a terrorist is doing something to the national level, immediately he will be booked. There is no question of asking any. There is big I don't know. Something like that. I will see the next slide. China. China is the most polluted. It remains the largest emitter with the ongoing increase of CO2 emission driven by quarterly consumption of natural gas. Next fellow, those who are in the top in GDP. Can anyone tell who is top in GDP? In GDP, who is number one in that? Not in the in the special lecture, like what I have been, regular class enough to but okay. Who is number one in the GDP? Even if it is my class, if you see, I will keep on asking a question. It is only to make you aware. At least after answering, you should keep it in mind. It comes to, which is what number one? China. Anybody answer? Any other answer? In GDP, AES is number one. Number two. Why I am asking GDP? Is something irrelevant? It is irrelevant. In this modern world, it's a GK question which any engineer should know. And particularly you should know because it is related to your energy sector. If you see the energy and GDP rate, almost it matches. That means those who are producing those energy is leading the top position, going to the top in GDP. Second is China. Third, third German, somebody told me. Fourth only India. Fifth, Japan. Recently we were working. Just 2 to 3 months back we were working. We were in 2013, we were in 10th, 11th position. Now it is 2024, 25 we reached the from 5th to 4th position. And our projection, you know, by 2029, the next year we will reach 3rd position. We will immediately overtake Germany because a little bit difference. But to reach China and reach America, target is fixed. 2047, when we celebrate 100th Independence Day, we should have number one rank in our GDP all over the world. That is a projection by which our government is moving. Okay, China is the first country, US is second. If you see and India third. So that is the reason why these countries are moving fastly towards renewable energy. Okay. And there are other people. So global emissions by sector wise, if you see, energy sector is the dominant source, responsible for almost 78% greenhouse gas emission. And sector includes emission from electricity, heat, 29, transportation, 39, manufacturing, 12. There are different sectors contributing independently from different sides. And primary drivers are combustion of fossil fuel like coal, oil, and gas. Okay. Now we'll summarize why should we switch over to renewable energy and what are the problems we face in conventional systems. So this table will tell you what is that. So in the fossil fuel, if you see, non-renewable finite source formed over million of years. Fossil fuel is available, but it is taking lot of time to get formed. 100 years, 200 years back, 500 years back, it started forming this, and now it has reached the form of coal or even anything, whatever you take from the air. It's not immediately. And it has an emitter source. If it is completely removed, what you will do? That's all. It is going to exhaust after some time. If the consumption rate goes up, if the available fossil fuel comes down, at one point of time it will be wiped off. Then what you will do at that point of time? We cannot immediately change over with a heavy load on the system. After completing, reaching zero position from the fossil fuel. We cannot immediately. So slowly, when it reaches zero, you have to switch over to some other technique so that we will retain the power in the. Okay. And second, what are the example of coal, oil, natural gas? These are all example of fossil fuels. Whereas renewable energy, solar, wind, hydro, thermal, and biomass, and tidal energy. Okay, environmental impact. If you see the significant greenhouse gas emission, that is CO2, is greatly available. Whereas minimal lifetime emission create far lower carbon footprint. It doesn't mean that it is zero. It is little bit. So comparatively, whoever is having a little bit emission, you will choose now. Once this curve becomes culprit, then we have to switch over somewhere. So currently we have to see the trend. Sustainability, unsustainable due to their infinite nature and environmental, whereas this is available. Sustainable because their sources are constantly, because water is always available. Air is available. Light is available. It cannot get exhausted. It completely comes for a long period. Okay. And formation created from the remains of ancient plant and animals under intense heat. Whereas this is a natural process from sun. And the major source for all this energy is what? I'll ask this question to anyone. Getting a lot of energy, wind energy, tidal energy, which is a major source for all this energy. Sun. Solar energy is a primary responsible one. From there only everything comes. Like solar comes and produces heat, the water gets evaporated, then it becomes rain, and solar light comes with the air. It is a main source. That's the reason why we people immediately pray sun as a god, Surya god, because that was the source, starting point for the entire universe. Okay. Availability will eventually be updated because after the completion it's not going to be available. Whereas this one is inexhaustible. It's available always. Human, as long as the human is there, water will be there. As long as the human being is there, we cannot live without sun. Okay, so what are the available sources available? Solar energy, wind energy, hydroelectric power, biomass energy, geothermal, tidal. All these things, though I have told the names of different types of renewable energy sources, the major thing only solar and wind, because it is currently viable, possible, practically approachable, and it is helping the power producing sectors to increase and manage the load while wiping out all the thermal and the conventional power plants which are all polluting the atmosphere. Okay, so these are the different sources. Let us say that what is the total power production if you see in India, almost we have reached 490 gigawatt. Previously we used to say megawatt. Started from kilowatt, reached megawatt. Now currently we are in gigawatt. Giga means 10 power. Giga means 10 power. 9. Tera means? Okay. Because today I am talking about giga. When you reach 40 and 50 age, you will talk about tera. Because energy demand, energy demand keeps on rising. Everyone is power dependent. Electrically, if you don't have enough amount of source, you cannot maintain your load. So this represents, you see, almost you have reached 490 gigawatt by July 2025. This is currently available data. And this represents nearly 137% increase from estimated 207 gigawatt in 2014. 2014 we are only 207. We have almost doubled, more than doubled, I should say. Okay. Its expansion of renewable energy sources, especially solar, which grew from 2.8 in 2014 to 116 gigawatt by year. So 116 gigawatt almost you have touched in solar growth. And thermal, there is thermal power. Though the steel largest contributor has seen its share decline as non-fossil fuel capacity has rapidly increased. Currently thermal is still leading. If we take the current scenario, thermal power production is only leading. Almost 65 to 70% of the power is coming only from thermal. Because Adani have invested, we cannot stop. They will lose power, they will lose employment, they will lose money because money is invested in all the equipment. Boiler, generator, transmission, everything is inside. Immediately cannot. I can do immediately. If you have equivalent amount of power in the other side, you can close it. And you should have, economically should be strong. Because it's going to be risky. So till we become economically strong, till the energy sector, the renewable sector is coming up, we will keep on using this. At one point of time, it will be removed. So, if you see the overall contribution from each sector year-wise given, 2025-26, if you see, that black one is coal. Coal is still leading. And the yellow is solar. And solar are categorized into different solar ground mounted, solar rooftop, solar hybrid, solar off grid. Solar has so many classifications now. On grid is connected to grid, off grid is standalone. And hybrid means solar not only will produce, we will also produce wind and we will go for hybrid to increase overall power to push into grid. Okay. And rooftop means only for small scale, for domestic applications we used to say. Everyone is having, anybody is having a solar plant in your house, solar panel in your house. No one is having. I asked that person who was in that field, he said around 1,500 to 2,000 people in Pondicherry have solar panel because government is giving concession. I'll tell about it. So this is a scenario, it is on the rise. Now you see the rise in the yellow. Yellow keeps on rising from 2019-22 to 2025-26. And power level goes up. Power is still increasing. So little bit thermal increase is also there. But this will tell you how we are going to meet the demand. Okay, this is a overall load in the system, including both renewable and non-renewable. But what is, if you see the pie chart allocation, I'm showing a different way. The 2024, if you see, almost 70% comes only from coal. Okay. And the other hydro 7.6, nuclear 2.7, and gas 2.8. This is allocation. The 23% is low carbon. The 23% is coming in the almost 1/4 of this entire circle. It comes from low carbon. That means from 0 to 1/4, 20% we have reached to control the emission rate. But still 78% is contributing for pollution. These are different types of load you should know. Because unless you know which type of load you are using, that follow you can ask him to switch over to renewable. So if you see the industry, 42% is only industry. And 25% is domestic. Domestic you can say, go for you switch over to solar plant. You can have your own plant. Government is giving concession. Okay. Because I was asking yesterday, I was telling, 3 kilowatt panel if you go for solar power production methodology, he says you have to invest 2.1 lakhs. Maybe 4 to 5 years payback period. After that you will get them. And once you use for 3 kilowatt, you can run for he's telling the 3 to 8 hours, 20 units you can produce, 24 units roughly. If you want, you can have battery backup and you can take it from night. You can have a standalone, or if you want to increase beyond 3 kilowatt, if you go for installing in your house, you can pump the power into grid by connecting with the interfacing system, proper interface system. That is also allowed. People are doing that. There is a meter, smart meter is connecting between the grid and your solar, and it measures the power in both directions. When you pump the power to grid, it measures in this direction. That will be notified and you will be given a concession or you will be paid for that. If you consume power from the grid to your side, since solar is off, you'll have to pay. And if both sides, there will be you have to see the difference. Okay, so this is how it is going. So industry, I can give concession. You start your own power, you start your own wind farm. Wind is only with the industry because it's a heavy amount. And once a wind farm is erected, installed, commissioned, then they can pump the power into the grid, and they will come for competitive price bidding. And government has to pay the money for every unit of, let us say, 1 unit. I will pay 4 rupees. It keeps on feeding power. They are getting power from the government after installing. Agriculture is the one which is not touched because agriculture in some states they are giving at free of cost. If anything is given at free of cost, they will not touch it. If something is given at full value, they will concentrate and they will do. So there are commercial to some extent we can go for solar. Others 8%. The current situation, if you see the potential, and I have given the current available rate. Solar is having 89 gigawatt, wind is 47, large hydro power. Hydro is coming in renewable energy or non-renewable energy. Since I put here, you should know that it is why it is renewable energy. Because some people will think that the hydro power plant is studied along with thermal power plant nuclear. They will think that no, it is not a renewable one. It is a conventional plant. It is not so. Why we segregate that into renewable energy? The source what we use is water. What is available on this? Water, wind, solar. These are natural sources available. Renewable energy keeps on coming. Renewable. It is renewing. I am not going to get somewhere and I have to pay cost. It is naturally available. At any time I can take, I can do anything. I can use power, I can sell power, I can do if I have proper device to make power from that source. And biomass, 10 gigawatt. So they have this kind of. Now we'll go to solar energy. Shall I continue? No problem. I will continue. So solar will fastly finish. Many countries and territories have installed significant solar power capacity with electrical grids. And first one is photovoltaic system and use solar panels. That is a rooftop type. Second one is concentrated solar power. The concentrated solar power I will not discuss. I have slides but I have removed it because it taken a lot of time. And it is not much in use. But first photovoltaic PV systems is widely used by many industries. Separate for producing the projects are available from the government side, private sector side, individual customers, individual residential consumers, all those people are having because now the rate has come down. Is that at 2.15 lakhs I have to pay for 3 kilowatts and the government is giving concession. That is also there. 75,000 government is giving. And the remaining also if you want to go for loan, it is eligible. You can go for loan. They are telling 6%. If you go beyond 3 kilowatt, concession is same 70,000 totally. What will be the amount you invest beyond 3 kilowatt or below 3 kilowatt? And the rate of interest in bank goes up if you invest more than 3 kilowatt. But you will get the amount and it comes for 20 to 25 years. Minimum 10 to 12 years they are giving guarantee for physical information. If anything happens, they will come and take care. And maintenance also they take care. After 20 years it will come. That means minimum 5 years you have to get the money from the investment. Because somewhere if you invest money of 2 lakhs, you get interest. That interest you should get. So you get 4 to 5 years to get the interest of that because you invested large amount of money, so you'll have to get. After the 5th year, you will be getting profit. And this will come for another, if you say total pay 20 years, 20 minus 5, 15 years you will be getting profit. So totally it is only profitable. It's not, people will say, initially you have to pay. Even for that government is giving concession, you can even go for loan. So government is coming down to make all the people to have their own setup. Once that is made ready, automatically can go for and you don't have to. Solar PV systems, I don't want to enter, I will not enter, I will give a data. But these details already must have studied. Renewable energy, particularly, I want to know whether you people have studied the subject renewable energy. And continue with without makeup, so all of this we should not be audible. It is audible. You can even occupy them. People are sitting at the back and occupy the front seats. Thank you. Okay. The solar energy, have you studied renewable energy paper? Anyone can answer this question. I think that specs, yes. You stand up and tell. Yourself. Green shirt. Light green. Have you studied green energy, energy engineering or renewable energy? Any paper related to this topic? Because I would like to know. படிக்கவே இல்லையா படிச்சீங்களா என்ன ஓப்பனா சொல்லுங்க வாதியார் ஒன்றும் சொல்ல மாட்டாரு
Not yet at the college. College.
இப்போ நீங்கள் ஃபைனல் இயர் தான் படிக்கிறீங்க ஃபர்ஸ்ட் செகண்ட் இயர் டெஃபினெட்லி செகண்ட் இயர் ஃபைனல் இயர் யார் இருக்கா ஃபைனல் இயர் எழுதிருக்கா நம்ம ஓகே ஐ திங்க் யூ கேன் ஆன்சர் யூ கேன் ஒன் ஆஃப் யூ கேன் ஆன்சர் அவங்க படிச்சிருக்காங்களா ஃபைனல் இயர் 8 செமஸ்டர் தான் இருக்கா 7th 6th 5th ஓகே. So this PV cell, because if you have already studied, I will fastly go. Anyhow, I have only little bit time for this. I will not contribute much because I have to touch other sources. When photons from sunlight strike the semiconductor material, typically silicon, within a PV cell, they exit electrons, causing them to flow and generate an electric current. This is a fundamental thing. But I have studied in PN junction diode, and forward bias increase the voltage, so it starts conducting. So between the P junction and N junction, there is a barrier, and the depletion here has to be broken down. To break that, we have to do some kind of energy, maybe a heat or maybe it's a voltage. I have to do something to make it turn on. Okay. So this direction conversion of light energy into electrical energy occurs because PV cell semiconductor layers create an internal electrical field that facilitates a movement of these electrons. Okay. So this is a fundamental picture everyone should know. From the sunlight panel goes and it goes to electric current charge. The controller is to maintain that voltage to the battery level because your production voltage may be different, your battery voltage may be different. So you have to get the proper voltage and you have to have a proper controller, and that should be connected to inverter to have AC, or if you have a DC load, directly can connect to DC load. So it's a basic structure. And this is the internal structure how the panel works. You have a sunlight falling on those lines, you see, and P type is there, N type is there, N type is at the top, and P type is at the bottom. In between you have a depletion layer. So when sunlight falls, automatically it starts conducting. The substrate base is available at the bottom. And if you connect anything between this top and bottom with the help of voltmeter, you are able to read the voltage of 0.58. That means current starts coming. Only when the voltage is available and if the circuit is closed, current will come into picture. If there is no voltage, circuit is closed, no current. If the voltage is there but circuit is open, no current. So for current to flow in any circuit, you should have a voltage source and you should have a closed circuit. Okay. So this symbol we are seeing. So this is a conception how the cell is developing your power. What power it is producing? It's producing DC power, AC power. Solar cell is producing only DC power. So there are three major categories of cells. First generation, second generation, third generation. They say the first generation they say monocrystalline and polycrystalline. And monocrystalline is the high efficiency, longer, and whereas the polycrystalline is more cost effective, but it is not that much efficient. I will not go into the details of those things. Just I am telling what are the types of cell available. The second generation, we have a thin film solar cells, and these cells are using the material of silicon, cadmium, and gallium selenide, and it is more flexible, less expensive to produce and perform well in low light conditions. The light is low, you will have to choose your cell based on your environment. If the sunlight is good, you have to go for efficient one. Sunlight is bad, you have to go for accordingly. Lower output power and efficiency and shorter lifetime. These are the drawback of this. And third generation is one which is now emerging, and this heterojunction technology combines the different silicon types like amorphous and crystalline to improve the performance. And there are other types like bifacial cells, perovskite cells, and dye sensitized solar cells. So these are all different types of cells. And let us not. We'll go to this. What are the factors affecting the solar power plant? Only increasing the usage of solar. If the efficiency of the solar panel is 5%, it was 25 years back, we will not come into this because after heavy investment, if you take only 5%, it's not worth it to do. So people will normally switch over to the best efficiency. Particularly electrical engineers will do, and you talk about the efficiency of all electrical machines. If you use this kind of low efficiency, now the research is going in the solar panel side, how to improve the efficiency, because that is where the efficiency can be. Once the electrical current comes in the picture, electrical line efficiency, everything is good. We don't have proper, we have a proper system. We don't have major loss. Loss is curtailed to minimum 10 to 20%, 25% you can manage. So how the practical development efficiency of entire solar plant is lower typically in the range of, because solar panel itself 20 means overall solar plant efficiency will come down from that, maybe 50. So that is one drawback of this technology. And if you see, these are the different components I am using. So from solar I'm producing power and I'm going to charge the controller, then it is going to control. Then it is given to AC with the help of inverter, and it is also having a monitoring system to control all. And DC side I'm also connecting with battery. Battery is normally connected because sun is not available all the time, because you have to depend on, during night time you have to depend on battery if you are a standalone method. If you are not having a standalone, if you are grid connected, you can directly take power from grid from the night. But in the night time you can at least avoid power taken from the grid during the daytime. If you are capable of producing power excessively more than your load, then you can export power to grid. That is also possible. Okay. So then once you make the power transformer, it goes to grid. Okay. So even residential, commercial, everywhere is this. So instead of producing power and connecting the grid and coming back to residential, it's a very long line. If I have my own solar panel, it reduces the line. It becomes very short. Okay, it's a standalone system. Here I don't have any grid connected part. No part is connected to the grid. So solar, charge controller, battery bank, inverter, distribution panel, and it goes to AC load. In this, definitely should have a battery. Because in the standalone mode, you don't have connectivity with the grid. That means during the night, we definitely have to depend on power. So for that, I should have a battery. That means for designing such a system, there are some advantages itself. You don't have to depend on grid, whether that gives or not, even if it gives you charge at higher rate. There are so many problems associated with the grid connectivity, even charging, payment, fees, structure, agreement, all those things will come in. If I have a standalone, no problem. I am independent. Nobody can do anything with me. So in such a scenario, you should have a proper battery. Battery will be the culprit here. If you don't maintain the battery, if you don't invest the battery, then it will collapse. Because during the night time, without battery, you cannot start. So grid connected system, just one simple model I am showing. So from the solar panel, now if it is possible to put it in the roof side, it's a rooftop. That is it, they are telling the solar rooftop panel. Rooftop is free. Nobody will do anything on that. So that place can be used instead of putting a separate solar panel on the open terrace where people can go and play instead of disturbing that area. First preference goes to solar, because that area is always exposed to sun. And if the sunlight is taken from that point, and we will also get, because sunlight is not coming to the house, we are also getting cold. We don't get heat, because heat is taken away by the solar panel. And solar is also doing the job of producing power for us. So we are getting two advantages. One is we are not getting the heat. Second thing is we are getting power. So this is a grid connected system where the switch is available and home appliances have. If the power is not available during the night time and if I don't have a battery, I will take power from the grid. So government support. What are the government supports? I said PM Surya Ghar, Mufti Bijli Yojana is a scheme where people are giving concession rate. MNRE is also involved in that, and PLI schemes are only for larger sectors. Now we will go to that. They say in the scheme what they provide, up to 2 kilowatt, 40%. With the 60% covered up to 2 kilowatt, 40% for between 2 to 3 kilowatt. As the kilowatt rate goes up, concession also coming down, because who will approach for higher watt? Wealthy people. So you need not give much money for concession for those people. So for lower people, below average, they are giving 60% concession. Okay, he said roughly 80,000 rupees for 1 kilowatt. That means if you go for 3 kilowatt, 2.4, but they say 2.15 lakhs. More than that, it becomes 80,000 per kilowatt. Suppose if you go for 5 kilowatts, they charge per kilowatt rate 80,000. That means 3.5 lakhs, or almost 4 lakhs. 10 kilowatts, 70,000 becomes 60,000. So per kilowatt rate they are fixing from 80 below that 3 kilowatts, and from 3 kilowatts to 5 kilowatts 70,000. And as the power range goes up, they are reducing the cost, because when we are buying anything in a bulk, we expect that some kind of subsidy. So they are giving. This is available. You can even, if you want to have, you can have concession rate solar power in your house. There are people, I have a address. If you want, you can approach any, many people are selling solar plants. You can approach anybody. Government is giving concession. They themselves will take care. They themselves will take care of all the panel fixing, everything, connectivity, purchasing equipment, dealing with the EB people for grid connectivity if you want. All those things they will take care. Only thing you have to pay money. If you are not capable of paying money, you can go for bank loan also, 6%. So it has become quite easy for you people to export power to grid, even in this situation. Okay. Okay. So we see that anyway, industrial, commercial sector, there are a lot of schemes they have. Production means production. PLI scheme means production linked incentives. If somebody is producing something, they are giving concession. So this incentive is given for the people who are producing large amount of power. 20 years back, all the semi installed, they be buying a wind farm bond. When the wind mill is producing a lot of power, they generated a lot of wind farm for investment. All the people who are wealthy, semi installed, they were buying all these wind farm projects in terms of lakhs, because the concession was given. Tax was free. Tax free method. It was adopted long back. Many people are having wind farm bonds. They have invested. It is still available. So government was giving protection to this sector to increase the power level. Okay. So MNR is also doing. There are grid connected rooftop solar systems. Pradhan Mantri Kisan Urja Suraksha Evam. So a lot of schemes are available in them. So you can refer and you can go according to your concern. But we will not come under this industrial and commercial sector, because their rate is high. Our rate is low. Not only rate, even the magnitude of power that we produce is only maximum 10 kilowatt will go. Will you go for 100 kilowatt in your house? Nobody will go. Even if you are a richest person, will not go. Whereas industry, minimum itself 100 kilowatt, because their expectation is more, because the load is heavy. And commercial, they will also go. So there, the concession will be less, because they are all doing business. We are running our basic line. So that is the reason why concession is more for lower category people. This is a big stuff how the Indian renewable energy sector. Solar is contributing almost 57%. Wind is 32%. Biomass, small hydro, and there are little bits. You can even ask me why the tidal and geothermal is not coming. I tell you when it comes. Okay, before that, I last asked, which is the largest solar power plant in the world? In the world, I must say. I have taken data from the world, comparing many countries. In the country, comparing many states. It is only to know who is leading in the world, who is leading in our country, in the form of states. Anyway, the largest solar power plant is Batla solar plant in Rajasthan. Because Rajasthan is a very hot country, all of you know. It is having, the temperature is very high, desert is there. So that is a more suitable place for fixing all your solar power plants. So that is why people are making a lot of investment in that. And the solar park in Rajasthan, India, the installed capacity of 2,245 megawatt, which is almost equivalent to one thermal power plant. Maybe NLC can take, maybe Mettur can take, Thoothukudi can take one thermal power plant with a lot of units, unit 1, unit 2, unit 3, phase 1, phase 2, phase 3, they have a lot of division in them. That way. And covering area of 40, the problem with solar, another big problem with the solar, it's not problem with the residential sector. Problem with the industrial or even commercial sector, if you see, the problem is vast area. Because power will be taken only if solar panel is spread out throughout the space. As long as you increase the space of the solar panel, your power production capacity increases. That means it occupies more space. So that's the problem. You see, it is occupying almost 14,000 acres. But if you see, maybe 300 to 400 acres. But the same 2,000 megawatt it is producing. So that is a drawback of this solar. But this is not a drawback for wind. Wind is also exploiting the large amount of gas, large amount of power. Wind is also exploiting large space. But the advantage is between the between the wind the hub, you see, I can use for farming, I can use this allowed. Only the place where the windmill is erected, I cannot use anything. The other area is allowed. In the total area of 1000 acre, I may have some 20 or 30 plants, 30 windmills. Then other area I can use the remaining area is allowed for this power producing wind plants. Okay. Okay, I'll finish this solar, then I will stop. Then after a break, we will start wind. Okay. Just I'm showing the picture of how the Batla Parks Rajasthan result 2245 megawatt. You see the area it occupies 14,000. You cannot go there and see, but you can see from here. This line. It's the largest one. Okay. Largest one in town. This is another view of this. How much area it occupies. You see. Okay, we will stop here. So, but the drawback, what I want to mention here is lower density. So, you see, typically, if you see the range, it comes around 1.5 to 19 points. And 19 points comes to the maximum possible extent if you do lot of work. Roughly, you can say 10 because it is shuffling from 1.5 to 20. But when you compare this with the conventional plants, fossil fuel based power plants, it is hundreds watt per meter square. So that is where we see it consumes large amount of area. Because of lower density, it means a lower power, the solar power requires much larger physical footprint for the same power. The crucial factor for land use, planning, and infrastructure costs when deploying large scale clean energy schemes. Okay. But it is abundantly available. Power density is low. That is what I want to stress. This is a diagram which will tell you our country is a tropical country where we are eligible to get exposure to the sunlight maximum possible. Because we are coming in the almost in the equator region. In the equator region, if you see the middle of the earth, surrounding the equator line, up and down, 10 degrees in variation, if you see all those areas covered in that, will be called the equatorial region where the sun exposure will be maximum, where it can tap the sources effectively for your power producing process. And if you see the world rank still now China is number 1, produces almost it has got the installed capacity of in terms of mega data. And if you say in gigawatt, it is 887 gigawatt. USA comes second, India comes third, and Japan, Germany goes, and South Korea is the last one in the top 10 category. And if you see in this, China and South Korea, Japan, they are all mostly out of 10, 3 countries are coming from Asia. Okay. And power production, if you see 1 and 3 and 10, it is much more. So Asian region is almost tapping the source of electricity. And in our country, if you see Rajasthan, Batla Solar Park is one which has produced a large amount of power, having 2,245 in a single place. Okay, 2020 it was erected. It is the world number 1, and we are proud to say that it is in India, particularly in Rajasthan. And if you see Karnataka has got 2050 megawatt plant in 2019 it was erected. Similarly, if you keep on seeing, finally Tamil Nadu comes almost 7th or 8th in the rank. Kamuti Solar Power Project is having the capacity of 648 megawatt power plant. It's not the overall ranking, it's a power plant which is available in the different states. But if you want to see the overall ranking of Indian states with respect to total country contribution, you see the top solar states, Rajasthan comes first. It's a hot area, hot desert is there, already know. So that is the first and foremost state to exploit the maximum possible energy of solar. It is almost having 33,467.98 megawatt. Okay. And Gujarat comes to second position, 32. And Tamil Nadu, 24,000. Karnataka, 23. Maharashtra, 21. And Andhra Pradesh. It's like that it goes. The top 5 are just shown, and we are in position 3. And if you see, there are different types of mountains. Ground mountain, if you see, it comes to 66,980 megawatt. Grid connected, 11,000. That means, though we have the total capacity of 81 available at the top, grid connected is only 11. That means 70,000 is standalone. So, if that is increased and it is pumped into the grid, then grid can contribute power to any region. So, the connection of power to the grid is depending upon the power line. Normally, in the residential area, still many people don't have grid connectivity. The reason is power that is produced from the household appliances, from the solar, residential sector power production. If you see the solar category, it's very less. Yeah, little bit you can get, maybe transfer of energy from that to this to that. If you see, you get some concession, but it doesn't contribute much for the growth of the entire nation. Who can contribute separate solar power plant? There are so many agencies that are making this project. Okay? There is association for doing this. And the private sector are paying right now. The government is giving a lot of incentives for different schemes. So unless a very big push comes from the government side to push the energy into grid, we cannot. Because out of 88, off grid is 2,000, but even the grid connected 11,000. Other things are either taking grid power or giving grid. So it's a mixed scenario. And this is the final pros and cons of solar. So 100% inexhaustible energy is renewable and free. Okay. No toxic, it doesn't pollute anything. And it doesn't depend on fossil fuel. Electricity bill, it reduces. Subsidy still it is given. But the subsidy, I don't know how far government will give. It will be given for some period to start the process of, to initiate the process of installing all types of thermal power. Once it reaches a considerable, comfortable stage, then automatically it will be cut. Okay, because you will be comfortable. You don't still depend on it. Since it is in the initial stage where the very big push is needed from the government side, they are giving concession. Reduces the need to rely on the electricity grid or natural gas. Because if I don't have to depend on the grid. And it is environmentally friendly. Okay, it is almost equal to second. Whereas if you see the intermittent energy is not available throughout the day. Only for daytime it is available, night time it is not available. And high initial cost. Initially I have to, even for 3 kilowatt I have to go for investing 2.5 to 3 lakhs. Gold to this. Maybe middle class and above middle class, upper middle class. Lower class cannot think of this. High initial cost is a big problem. Location of the home, all everywhere you cannot do. Only the sun, some area always gold. That OT, all the hill stations they may not have, but they may have wind quality. Because always sunlight is not coming with good intensity. So you have to see the location. If my location is in OT and always cold, even if I have even summer season, it will be little bit. But my investment is heavy. I am not able to get back the amount invested. At least 4 to 5 years payback period, I have to get the amount. If I don't get, then I will get lost. So people will not. So location is another important factor. Variety contacts. It also depends. Even during that daytime also sometimes light will come down, rainy season will come. That will affect the system. And the energy storage is expensive. You have to go for battery if you want to store. Battery is another thing. Even in the electrical vehicle, what they say is motor, all the other things will be there. Battery is a culprit. He is a fellow who is consuming large amount of money. You want to replace the entire battery, almost 40% of the total cost of the vehicle it consumes. Other things are not that much, but battery is a big. That is the problem of battery-oriented technology. That result, when they do research, they will come out with a suggestion to minimize the cost, maximize the storage capacity. At one point of time, it will reach. Now, how the solar has reached the stage where it is available at 2.5 to medium rate. The cost of the solar is very cheap. And uses a lot of space. Yes, space occupation. I was telling that it was having the low intensity compared to all the other power producing methodologies. Because everywhere you have to spread that. Like a bank, you have to spread your solar panel. As long as you keep on spreading, occupying more area, but power putting capacity increases. That means I have to occupy more area. That is the reason why in residential system that problem doesn't arise if they fix it in the rooftop. Okay. So time consuming is another problem. So wind power plant I will shortly finish because So taking power from solar, I can also take from the wind. Wind is also contributing a lot. After solar, wind comes in the next category in the renewable energy sector. If you see in our country, second largest renewable energy source, if you want to mention, naturally it is wind. So wind again, I don't want to discuss much because it is rotating. Kinetic energy of the movement of the blade by the pressure of the wind moves a generator inside. Once the generator runs, it produces power. There are different types of generators already. This power can also be fed to individual loads and it can be connected. But mostly if you see it is grid connected because it is not a single wind mill I am having for my own purpose. The problem with that type of load is for a 6 months period you will not get wind. Maybe another 6 months you will have. Some area it will be coming with a little bit pressure throughout the year. Some area will be very big pressure during some specific period. After some it will keep on coming down. And 50% of the time if you see in the whole year, you cannot get the proper wind. Sufficient, you have to get minimum sufficient velocity to run the blade of the wind. These are all the problems. But wherever it is available, you can accept. The problem is once you install, it will keep on running. You don't have to feed energy like fossil fuel you are feeding, coal you are feeding, gas you are feeding. Continuous feeding by nature. Continuous feeding like how the solar gives light, sun gives light. Here automatically your pressure of the air in that area, they have to survey. They have to take a survey whether this areas won't have this much possible, when it is available or not, they have to conduct survey, and if it is available, how long it is available in a year, they will conduct another survey. Considering all those things, because once you erect, install, you cannot remove. It's a very big problem because solar you can easily fix. This is not so because it is having a long tower. Fixing the blade, transporting the blade itself is very difficult. One blade itself will go for a stretch of 150 to 200 feet. And there are 3 blades and hub is good, and it has to be mounted on the tower. Tower is also big. Structure should be lot of complications. Once it is done for a larger scale, it becomes economic. That is why if you see wind always come in a group. Wind is always, if you see wind, there will be one windmill. There will be so many windmills. Because if you do collectively, it will be economical. If you do for one, it will be expensive. Okay, you can see even in Tamil Nadu also, so many wind plants are there, where the wind force is heavily available. Okay, so we will go to that. The wind plant converts kinetic energy of the wind into electrical energy. It's clean, renewable, sustainable, and plays a wider role in reducing carbon emissions. So India is among top countries in the wind capacity. The wind capacity we are still using. Okay. So here the generator, if you see, it produces electricity by the wind turbine. Wind turbine means the gearbox will be connected. I will see that. Everything will be available. I will see the diagram. And they are working this diagram until you understand. The blades are available, hub is available at the center, and it is connected to the mechanical brake. Then it is coming with the gearbox because gearbox speed is varying. So you have to get a constant speed. To get a constant speed, I have to connect a gearbox. When the speed is low, I will increase the speed to the gearbox. The speed is high, I will reduce. So that I will maintain a constant speed. The generator is available at the end. From the generator, I am taking the power to the grid, and power is available at the height of hub. And foundation should be strong because it carries the weight of the tower, weight of the windmill, the wind blades, hub. In the hub, when it is simply hub, it is a collection of gearbox. We have a brake system, we have a generator system. Whole system is coming in the hub. That weight will contribute. Blade is also having a weight. So all those should be accounted. So these are the different working principles. How the wind is captured, how the blade is rotating. Once the shaft rotates, the speed is converted into constant speed with the help of gear. Then the electricity is generated, then it is transferred to transmission category with the help of transformer. So what is the way that there are 2 types of wind. Okay, like what we see for solar. Solar we have solar panel and concentrated solar power system. It is very much lagging due to some technological drawback. In the wind, if you see, there are only 2 types of system. One is vertically moving, the other one is horizontally moving. Okay. The horizontally moving, the first one that I put here, that side is widely used. This is not much used, you will see that difference. The rotating axis of the blade system, parallel to the ground, that is called horizontal axis plan. The main rotor shaft runs horizontally, and inspection maintenance is difficult because it is available. You have to, for every mistake, any fault in that, you have to climb. inside, or you have to go with a ladder. There are some problems. They are more efficient. Above all these difficulties, that is the most efficient because they would have conducted survey that the wind force comes like this, when the axis is rotating like this. What is the velocity, what is the speed, what is the efficiency, what is how much power it is produced. When it is rotating like this, what is it? So after the rigorous analysis, they come to the conclusion that the horizontal is producing large amount of power from the wind, whereas this vertical is not that much. So that is the reason why that horizontal is playing a wider role. So coming to the vertical, we see rotating axis is vertical, all of you know. And inspector maintenance is easy because it is available at the ground. Ground itself, you can go into any repair work. They are less efficient. They can operate even in low wind speed. So these are the advantages. But to my opinion, if you see any wind farm, it's only the first thing, the horizontal only because of efficiency. Because when you go for a larger scale production, if efficiency of 1 mill is good, then if you have so many wind plants in the wind farm totally, the wind turbine, each let us say turbine, there are so many turbines available in the wind farm, let us 100. If each one efficiency is improved, the 100 into, it will give an overall efficiency improvement and it will feed large amount of power to the grid. Normally the wind is scattered to the grid because mostly the area where the pressure is available, people don't like to see the remote areas, the hilly areas. Even Tirupati also whenever there are plants. Even in the Kayattal, Aurangabad, Tirunelveli, when we go there, Tirunelveli is the best for power production. Its air quality is good, wind mill is producing, solar is also coming up. So Tirunelveli is the best place, southern region of our Tamil Nadu. There you can see lot of windmills are there. And these are all different types of horizontal and vertical blades. Just to have an exposure how the blades are. I mean, there are different types. 1, 2, 3, mostly 3, because that gives large amount of energy. Okay. Horizontal is only little bit and the rare use. Types of generator, we have a DFE generator, what is called doubly fed induction generator, and Beckman axis generator, and also we have squirrel cage induction generator. Finally, other bit of the when you give a mechanical core, it develops electricity. There are different types of generators. Normally, DFE is mostly used. You see, is it stacker? Here, power is going from sleep. You move from the cursor here. The cursor move from now. You see it there. So, because I want to, the DFIG2, that US load side, power is directly transferred. To control the power of actual power, active power from the source, DFIG to source, I have another grid connected rotor side converters. That is the rotor side converters with the grid source converters connected in between the capacitor. It's a DC source. This is controlling the actual power flow from the DFA, that is fed into grid. So this controlling mechanism I am using with the help of closed loop system, using different types of converters. RSC is a rotor side converter. This DFA is having rotor, that is having winding, that is taken away, that is given to converters. And converted to DC, and the DC is converted to AC, and it goes to grid side. So second one is DC, that is a grid. The second one is grid side converter. The first one is rotary side converters. So this is mostly used, and these are different types of wind power plants. Onshore, there are wind farms located on land and form the vast majority of India's wind energy capacity, 50 gigawatt as of 2025. 50 gigawatt. Muppangal wind farm in Tamil Nadu, 1,500 megawatt. Normally we see in Tamil Nadu. Jaisalmer wind park in Rajasthan, 1,064 megawatt. Then Ramangal wind farm in Maharashtra, contributing 528 megawatt. So these are all onshore, that means on the land. We also have offshore wind power plants located in coastal areas, particularly in seas, are stronger. Because in the seashore side, if you see, the wind pressure is low. They say after conducting a lot of survey, you would have seen in the evening time when you go to the beach, lot of in the sea breezing will be there the evening time. So always in the seaside, the air pressure will be more. So if you erect all the wind plants in the seashore, that is in the offshore plants, you are able to harness a large amount of energy that can be used for generating electricity. So India has identified about 70 gigawatt potential options. 70 gigawatt is available potential we have. The plans and policies underway for large-scale offshore projects, primarily of Gujarat and Tamil Nadu. Gujarat and Tamil Nadu is leading. The hybrid wind is also there. Hybrid means you are connecting one power plant with another power plant. I have a solar power plant. I am connecting wind. Why should I do that? Because if all the power is produced in one state, we can have a power station, we can have a grid nearby. I can connect to the grid entire power. So all the instead of connecting is separate. If I have a same transformer, same line, it will be cheaper in terms of my investments. So that is the reason why they go for hybrid. Gujarat is doing that. Gujarat, if you see the largest solar power plant, they don't only have that particular solar. They also have wind. Put together large amount of energy is available in one area with the help of transformer. They raise the voltage and they pump the entire megawatt of power into grid. The grid becomes stronger. It can spare load to any extent, any area. So largest wind farm in Tamil Nadu, if you see, Uppangal, 1500 megawatt. Just I'm showing the diagram. And you see the Indian rank. India ranks fourth globally in wind capacity. Major states contributing for this fourth rank is Tamil Nadu, Gujarat, Maharashtra, Karnataka, and Rajasthan to some extent. If you see the GDP, the western states like Rajasthan, Gujarat, Karnataka, and Tamil Nadu is number one in south. In most of the cases, not only in wind power production, even in south. So education also, if you see NIR ranking, IIT Madras, NIT Trichy comes first. Lot of private like SR, many top level institutions coming with education hub. Tamil Nadu is an education. So it is not only education, it is also having very good GDP. In southern region, if you compare many aspects, we have a very good automobile sector. All automobile sectors are available. Even Madras, lot of IT companies. Though the sector it comes after Bangalore. Tamil Nadu is stopping in many cases. The overall growth of India, if you see, our contribution is much. And installed capacity is, they say, as of now, yesterday, because recent data I am not able to get. Only the last year data they will be available. It will be available to us. 40 gigawatt they have developed. And their aim is to reach 140 gigawatt by the year 2030. So, remaining 5 years, we have to not double, almost triple, more than double. 164 times. It is almost 3.5 times within a 5-year period they are going to. It means all states are going to compete and the concession will be given. It keeps on rising. Once it reaches a stabilized state, it will stop. So, top wind energy producing state, if you see, number 1 Gujarat, wind. Number 2, Tamil Nadu. Number 3, Karnataka. Are you able to see the pattern here? Gujarat. Tamil Nadu, Karnataka, Maharashtra, Rajasthan, Andhra Pradesh, Telangana. Those who are all producing large amount of power, that the states which are producing large amount of wind, solar, all types of power, only become powerful in GDP. And the installed power capacity in the world, if you see, China is first in wind, and after that we have United States, Germany, India comes in the fourth rank. That means 44 gigawatt we have right now. And following that, there are a lot of recent countries, Spain, and Greece, France, Canada, Sweden. They are all contributing to this because their energy requirement is less, population is less, area is less. Everywhere they are less, but they are good in many aspects. And this is the overall scenario of how the states are allocated in the wind capacity in terms of percentage. I am telling you the pie chart. And if you see here, Gujarat, as I said, becomes number 1. Tamil Nadu contributing 23%. After Gujarat is contributing 25%. Karnataka 12%. So this will tell you who is leading in wind power production to the growth of our nation. Because our nation is going to lead 4th rank. And if it wants to reach 1st rank, all internal people, all these states should contribute. So largest wind farm in India, if you see, it is in Kutch wind farm located in Gujarat. Now is part of Gujarat Hybrid Development. Gujarat, the largest number is Gujarat. Largest wind farm. Largest solar plant is Rajasthan. In a single place, they produce bulk of power. That produces power density. So this project was developed in the Adani Group and Suzlon, and it is a hybrid site combining wind and solar for an overall long-term renewable energy. So here we not only have you see, in addition to wind, you can also see solar panel. Solar panel is also available. So it is a multi-purpose. I am just taking the area because I am using the area. This is effectivity of energy producing system because in wind you are occupying area. Infinite area is waste. If you fix this solar, total power is available. When the total power is available in a bulk quantity in a single place, I can use transformer, raise the voltage, boost that into grid. Also boost that into grid, grid becomes powerful. Anywhere I can apply. This may be in Gujarat, Rajasthan, but I may use power from Kanyakumari because my grid is connected. Southern grid, northern grid, eastern grid, western grid, all the grid is connected. The power is coming to the grid. Grid will transmit power to any location in India because it's a national grid. Kutch wind farm, if you see, it is contributing 11% megawatt wind. And high grid, if you put solar, it comes to 20,000 megawatt. 20,000 megawatt, almost 23 gigawatt. I should say. So these are the details in this reference. And the largest wind farm in the world is the first. Out of curiosity, I just wanted to manage it. Gansu wind farm in China is the largest wind farm. And just to check that, I was referring to the magnitude of the power they produce. It is 20 gigawatt. 20 gigawatt power is produced in a single place in China. Okay. Our total wind capacity is 45 gigawatt. But in China, in one place, half of our total nation power is produced. That means they are the economies. They are still. So cost, if you see the wind energy cost, it comes to 2.8, 2.3 kilowatt, and it is varying from 2.9 depending upon the place, the location, your power it varies, but roughly it comes to 3. Okay, CERC will say Central Regulatory Commission is a one body which is controlling the tariff in our country. Solar, wind, because when the grid is having connectivity with all, if somebody competes, Adani Group will compete with the wind 2.5, Adani will come, Suzlon, somebody will come. Any power producing agency will come and give power at a competitive price. That flow gives 2.5, I will give it 2.4. Naturally, we will go for 2.4. So competition is very high in the wind power. That is the reason we are also getting the lowest tariff. The advantage is clean, renewable, reducing greenhouse, low operation cost, challenges, intermittent power supply. The problem is that the air is not continuously coming. First the problem. Even if the air comes, that's a 90 level is not constant for complete the duration of let us say 5 years, 5 hours from morning to 12 o'clock, 4 to let us say 8 to 12, then 12 to 4. But the advantage when you compare with the solar, even during the night time also, wind will be there. Wind force will be there throughout the day. There's no question of 50% off, 50% off like the solar. The light comes only. Of course, light is available since that is rotating, you are not able to do 50%. Only 50% you are taking. The remaining 50% is you are hiding. Okay, that is the problem. Of course, solar is always available. 24 hours it is available. We are getting only 12 hours because of the rotation. Wind is not having such problem. Wherever you take wind is available, but the problem is you have to conduct a survey. High initial investment is very high. If I want, I can make a solar power plant, I can invest 2 lakhs, I can produce 3 kilowatt. It's possible in my hand, but wind is not so. There is large amount of investment. Individual cannot do it. Rotate suitable wind size. Wind is not only that, lot of other issues. I have seen the selection criteria. Wind speed minimum 6 meters per second is the minimum velocity required for erecting, installing wind. If the wind speed average is well below 6 meters per second, then there is no question of erecting plant in that area. So minimum, if it is more than that, it runs at faster rate and it produces larger income. Land availability is another big area because air pressure will be available throughout the not any area will be available. In the area somebody is occupying, is not giving. So land acquisition is a big problem. If it's a government land, no problem, they will immediately stop the work. If it is somebody's land, private body or some other individual is having 500 acres and having, and let us say 200 acres, wind is there. If he doesn't give, what is the government has to do? make that for education. Unless you educate the people in this, it's difficult. Or you have to put a policy that wherever the wind was available, you have to give a concession rate. Suppose the GLR value is 100 rupees, I will give 150. Like that, you have to go for negotiating for people who are all creating problem. Wind proximity is another problem. It reduces transmission cost. If suppose the wind pressure is available here, but the grid is there. Wind is available here, no problem. I can immediately transfer. My wind pressure area is somewhere remotely located, almost 100 to 200 kilometers away from the grid. Then I have to transfer the entire power through grid. That means additional cost of erecting the transmission line from my wind source to grid. Additional cost. So that becomes accessibility. Because solar, any you can easily use. But here I have to carry the blade. Particularly the hilly areas, like in Tirupati, many hill areas, you see, carrying the blade is a difficult. But in 5 countries, they do with the helicopter. There are a lot of high-powered helicopters to carry all those things, and it is done. And it's doing all those things while hanging on the from the helicopter. Everything is done. Here it is still we have not developed the good technology to do all this. It's only on land-based, and only if the area is accessible by road, we'll go for erection. Otherwise, we will not. Yeah. Dependence on foreign expertise. That means what? Still we have not developed our technology to meet our requirement. Unless somebody comes from the foreign country who has already got very good expertise in that field, they can lead. But this technology from our side is not up to the level. Financial element is another big problem because solar wind is available at 2 rupees, 3 rupees. Solar is available at 2 rupees. 1 unit is 2 rupees. 2.5. Let us see. Even wind is 3.5. But if you see, it is not coming near here. It is somewhere. And the environmental risk is another problem, like the lava which comes. The nearby area there will be hot spring. There will be possible to, because hotness comes only from the earthquake. Most hotness you can see only in the volcanic eruption. So nearby area will be having less. So there you can assess. But the risk of going there, assessing the area, and other problems, environmental risk, these are all the issues with the geothermal. That is the reason still it is in the current status. If you see, no commercial geothermal power plants in India yet. Analyzed in various sectors. Still now, even in MNRE websites everywhere, check global search. Okay. Still it is not in the finally still in the back stage. The reason is, of course, though they have projected, though they have some idea, because of the cost factor, it is not able to produce large amount of power. Okay. So this is India is focusing more on solar, wind, hydro, and hybrid projects, but geothermal remains under research and development. That is the final conclusion. That means technology is not evolved to meet the demand. Tidal is a one which is freely available. It's a wave energy available in the seashore. You go to seashore, if you see waves are continuously coming. So even that also we can produce tidal power. Okay. So if you see that tidal, here also we see though it is available, but it is not continuously. Sometimes it comes, sometimes it stops. Magnitude of the variation, if you see the magnitude, it is also not uniform, it is varying. Sometimes big waves will come, sometimes. So sometimes even if you see Rameswaram, sometimes sea movement will be like a lake, really, no movement. Sometimes there will be heavy. The Tirupati side, if you see pressure, sometimes it will go back. Sometimes it will come back. It is not a constant. It is just dwindling back and forth. It is not in a steady state. That is the reason still we are not able to extract a large amount of energy. This is how it goes. When the high drainage comes, the turbine available at the bottom will try to rotate. Once it goes out, the rotation is connected to the grid, generator. Once the generator develops power, it will be connected to the grid. When the generator gets in between, transformer will come. It is understood. I don't mention. Because generated power will be at some voltage, maybe 230 or 500, whatever it is. But grid voltage will be different. So unless you produce, unless you make the transformer to meet the voltage, this cannot be. So here what I am trying to do is the wave energy, the movement of the water makes the turbine rotate. The problem is it is not continuous, and sometimes it will not be available. Sometimes the force is not uniform, it is varying. These are the issues associated with this. So India's estimated theoretical tidal energy potential, if we look at 12,455 megawatt, they have conducted a survey that this much potential in the earth. In coastal areas, they have also mentioned the name, Gulf of Cambay, Gulf of Kutch, Gujarat, and Sundarban regions. So these are the areas that they have identified for. The Gulf of Cambay alone has 70 megawatt potential. Gulf of 37,000. They have segregated the areas and analyzed the potential power for harnessing this tidal energy. So the advantage is we are having 7,500 kilometers the coastal line. That is from that side, if you see start from Calcutta, we go to Kanyakumari, then if you come this side, Gujarat, total length comes around 7. That means we are eligible to use. Some country cannot talk about this. Country which is not having sea, country which is inside Asia, having larger other countries outside with the border, where there is no connectivity for sea, and they cannot think of this one. We are having eligibility to think. But how far India can extract is another big challenge they are facing now with this technology. Still, it has not evolved to the maximum potential level. We cannot extract. Current status we see 3.75 megawatt demo plant in West Bengal they have done. And it was shut down due to economically and feasibility studies. Due to economic reason, this is a problem. Sometimes it will work, sometimes it will not work, sometimes the blades will get, because it is dealing with the water. So blades should not get corroded, it should not be, because blades are normally made of iron, so it will get the rust problem. So all those should be designed. So when you go for high cost, if you do pakka, if the waves are coming, everything is fixed. If it comes, little bit. Okay, it is coming, a little bit I am producing. That energy should be available. In the bulk quantity, I can pump it to grid. Even that is also another point. Okay, the 50 megawatt power plant in Gujarat, which is under development, construction is slow. What does it mean? Still it is not viable. At any time they will close. Planned and proposed projects include 250 megawatt power plant in that Gulf region, you see. And it's still collaborating with international. Now, the wind and the solar, they don't have any international collaboration. International collaboration comes only for geothermal and the tidal, because our technology is not sufficient enough to take the lead role in this region. The tidal power market in India reached about 2.5 megawatt installed capacity in 2024 and is projected to grow over 23 megawatt by 2030. With the rising government focus on technology. They said simply, but still it is in the beginning stage. Challenges, high capital cost, technological challenges. We don't have indigenous technology, lacks indigenous. That is the meaning. That means we are not developing any technological improvement in Thailand. Economic concerns, because the seashore, a lot of sea breezing, humidity, movement of the water, attacking the blade. So blade should be of high quality. Those should be looking. And geographical factors, suitable types, because the region is not having that much sufficient amount of tidal energy to produce power, then we cannot stop it. We cannot think of it. Financial viability is the biggest one. Above all, finance comes in. If you are financially strong, don't worry about anything. If you are financially weak, you will worry about everything. That is the problem. The current status, no commercial tidal power plant operation in India. When I say tidal power plant, producing power in a bulk quantity in a single plant, contributing to a particular region or connected to it. To that level, we are not at reached. Only feasibility studies and pilot projects are happening. Okay. So focus has shifted both towards solar, wind, and hybrid. Little lower cost. Here also they are saying, as they said for geothermal, same thing. Biomass, because still it is in the beginning. If we don't contribute much, I'll just fastly go through. It's a wastage of all the things like whatever you get from forest, animal waste, even sewage treatment, whatever the dust we produce, all those things are collected and that should be placed for producing power. Still, we have also not evolved much in that category. In February 2024, last year, data says that India's biomass power capacity has reached 10,940 megawatt with a focus on biomass, power gas, and biogas. Here, what is contributing maximum, if you see, the sugar plant Bagos is coming. That is easily burnable, you can use for producing power. And that steam which is getting heat from the Bagos can run the turbine which can be connected to generated developer. All the sugar plant, you can see the buffers waste product is coming. If that is effectively used in producing power, that is called cogeneration plant. That will produce power. So this kind of power is only coming maximum from this sector. Okay. The government supports the biomass sector through various schemes. Of course, there are schemes like what we have for solar is also giving, but still there's not enough. Current status, if you see, Maharashtra, Karnataka, Tamil Nadu are major contributed to some extent. Because where the people are maximum density of people, this will contribute a lot. And the type of plant is biomass energy landscape includes biomass power plant, desalination biogas plant, renewable energy needs, waste energy. So in the region where the agriculture part comes, we can use. And the sewage treatment plant that collected, nowadays even if you see in your house also, they collected two different things. Okay, biodegradable. It is only the oil and to use that in future for our power production. Okay, the government initiative, lot of initiatives there for this sector, I have given the data. For different program like Nation Biogas Program, Nation Bioenergy Program, growth connections. There are a lot of things government is supporting. The National Bioenergy Program, if you see, with an outlay of Indian rupees, 8 crore, promotes bioenergy development across India in the first phase, April 21 to 26. If you see, April 21 to almost 5 years, 88 crore they are allocating. And the power produces very less. That means still the technology has not evolved much as solar and wind is doing. So this will tell you overall power density of different. Solar is having 5 to 20. It is to compare all power plants with respect to solar with respect to power density. This solar is coming with the 5 to 20. Power density means lesser area, more power. That means power density is high. Onshore 1 to 2. Offshore 3 to 5. That is the wind plant. Biomass 0.5 to 1. Small hydro 5 to 10. Large hydro 0.5 to 5. Geothermal 50 to 100. The reason is hot water is directly coming in. All those things what we do. Even thermal also we produce. We take coal from the earth and we burn that heat, produces steam, that pressurized steam pushes a turbine that generates power. Lot of changes in the okay. Geothermal direct heat. So their power density is very high. Tidal to this is per capita consumption. You see, what is our per capita consumption? Anyone? In our country, every country is having per capita consumption. Per capita income, GDP, like what we say GDP. Per capita consumption means throughout the country, what is the power produced? Divided by the population tells you what is the rank. If you see that, ours is well below average. We are telling that I am producing large amount of wind power, solar power, even power production also we are third in the world. And GDP are fourth and we will become third. But this is the area where we are very much lagging. You see per capita consumption, we are touching only 1,330, almost 1,400 you can see per capita consumption of our country. And it is keeps on rising from 2006 to 2023. If you see the graph, there's a rise. But is it sufficient if you compare the world? Is it visible clearly? Iceland, Norway. Iceland is number 1 in the message. I will just need a maximum. The topper is Iceland. The flow produces almost 51,000 kilowatt hour. That means 51,000 kilowatt hour is used by one individual in Iceland for 1 year. That is the nearby proportions. Okay. And then Norway comes, then Qatar, Kuwait, all these things are coming. Canada is coming. Even US is also coming in the middle. I have taken the data only for comparing our level. Our level is 1,300. World data starts from 50,000. And in Canada, US, if we say, it is reaching beyond 10,000. So here I am comparing the countries installed in building energy capacity 2024. China is number one. In the renewable energy, power that comes from renewable energy alone, if we compare with the world countries, China is number one. So it is 1,837. And the US comes to second position. Brazil comes to third position. Now what is the position of India? That means in power production we are number 4. But per capita consumption we are very well below. What is the reason? Simple maths. Power produced divided by population. Since our population is very high, drastically it is coming down. Though we are good in power production, population is also very high, the number comes down. So this is only to show where we stand, and if you compare the top electricity overall, whether it is renewable or non-renewable, if you compare all those things, and if you analyze the power production, 1985 list is available. Let us not see those past data. Let us see the 2024 data. Even this China has overtaken this US, and it is producing almost 10,072.6 terawatt. The unit is terawatt. That's a tera. We were thinking about mega, now we are in giga, but China has reached tera. So 10,000 tera, whatever, 10,000 tera units they are producing, and they become number one. And the US is second, 4,000, 50% is down. It's not the 10,000, 9,000. And India is another 50% from US too. That is so. We compare with China, we are 150. That means still we need to grow a lot because China population we have overtaken, but energy that fellow has overtaken. That is the reason why they are in the top range of per capita consumption. So if you produce large amount of energy, you will be able to reach in a good position in the world. That Russia, Japan, if you see they are coming in the fourth region. And what is the problem? Why they? Because this is the graph which shows how the generation goes. In the 2018, 19, 19, 20, 2021 it is flat. The reason is Corona. There is a period power production. If you see the terawatt of generation of British thermal unit, it is very less. Okay, but still we are rising. Our rise, if you see, comparing the 2014 to 2018 data, if you see the current price is higher, still it is demanding a larger amount of power from the renewable energy. Now let us see the top power producing countries growth rate. Now you see, US was good, but China, the first one, the red graph, which was overtaken after 1995, 2000, it was in the third position. But after 2005, it was in second position, beating EU. EU means European Union. And after that, in the year 2010, it has touched the US, the China, the red entity. After 2010, the rise is not linear, it is steep. That is a region that follow comes to the number one position in the world. So China is developing large amount of energy. Okay, the energy production from China is very, very high. It is touching almost 10,000 terawatt. And whereas our growth, if you see in the fourth range, that is India, 2.1 currently, though we are compared to Russia and Japan, we are increasing. But the requirement is not sufficient. But our rate of increase is much greater than EU and US. EU is almost in the steady state. If you refer EU, that is also in the steady state. Whereas in India, rise is little bit higher than the US and EU. That is the reason why they say very soon we will reach a second position after China. But beating China, we have to, our growth rate should be much higher. Okay, considering what this is the last slide for you to be happy. So what's the future plan in India? They say in 2030, India's non-fossil capacity is expected to increase 61 to 60% and renewable capacity 510 gigawatts. So that is our projection. 2047, if you see, non-fossil capacity is expected to increase 85 to 90. Okay. And renewable energy capacity, the band is touching 1,800 gigawatts. Now total is 500 gigawatts. In 2047, we have to touch 1,890 gigawatt, contributing more, that is 85 to 90 only from the renewable energy sector. Almost this thermal power will be in the closed stage. Okay. So the renewable energy sector, why they have to 2047? There is a 100th independence. There is a reason there. Okay. So India's renewable energy capacity is expected to increase 170 gigawatt by March. So currently it is 170. So it is on the rising side. So India's renewable energy capacity is the fourth largest in the world. India's solar capacity is third largest in the world, and its wind capacity is also fourth largest. I am just giving this picture to see where our country ranks in the world scenario, so that people we can understand this sector is going to flourish. So all those electrical, mechanical engineers will have a very good opportunity in the renewable sector in terms of job opportunities, in terms of developing the skills. Next is electrical. So these are all central level bodies which are all contributing. These are the sites where I collected data. Ministry of Renewable Energy is one which is effectively functioning, the government said, and Solar Energy Corporation of India is another one, and Indian Renewable Energy Development Agency is the third one. CEC is dealing with all time. CERC is dealing with all time. Yeah, there are national institutes to do the research in the particular field, like doing research in the particular wind, solar. They have a separate institute available. This is a key international organization. This is where I collected some of the data. Federation Renewable Energy is giving all data. And then, that is renewable energy, 21st century. That is the reason they are capacity. So that is also dealing with this kind of